Hi. Okay, I have to do this again because I got cucked by OBS and immediately stopped recording me for no reason. I've been a busy bee the last 2 nights working on this, and what I've been doing is optimizing the fuck out of my code because it was getting kind of slow. I'm thinking, it really shouldn't be getting too slow at this point. So I went back and I looked very thoroughly at what functions were taking too much time. And what I found is that I had optimized my code as thoroughly as possible, and I'll show you in the jar. I'd gone to great lengths to make sure that it didn't have to do any searching. I keep all the dictionaries, cataloging what elements are in each tile very accurately and as it happens. And that's a pain in the ass. It's much easier to just have a giant list and pull from that list a derived value. Because you always run the risk of making errors and manual tallying. But I went through the effort and I made sure it works, and I added unit tests so that everything, if it does break, I can find out very quickly where it broke, and spent a long time getting that to work. And even at the end of that optimization, it was still rather slow, and I had kind of reached the end of my rope. I'm thinking, why is the C# implementation of the dictionary so poor? Why does looking up stuff and adding stuff and checking if a key exists take so long? And I found out that it has to do with a chemical, which is a struct. Now, in C#, the get hash code implementation on structs is used by things like dictionaries to create hash tables. So when you want to look up something that is a custom struct, it calls that get hash code, which creates a unique identifier on the fly. And because C# doesn't really know anything about your custom struct, it has to kind of guess a way to make a unique identifier for that hash table. So that is to say, it is much, much more efficient to go through and add your own custom implementation of the get hash code and the equals, because you can find out a way to make it unique for comparison purposes. That's probably much faster than the way that Microsoft does it without knowing anything about the structure. And the way that I did it is I added a CID, and the CID is derived from the National Library of Medicine's Compound Dictionary, which is extremely good as a resource for chemicals. And I just add that unique identifier from the NIH to it as the CID. And that way it is a unique identifier, but it's meaningful, and people can, add their own or verify it and what have you. And as I did that makes this get hash code a very straightforward static value for the structure. And that's about as fast as a comparison can get. It's just having a static integer. That's like the most basic component of a processor. So it runs really fast. And as I did this, what was something that I could only do about 6 times a second per tile, I could make 60 to 70 times per second as a tile. So if I go to the game, you can see that it's running 70 frames, which is about as high as Unity will let it run in the editor preview. So very fast. And even if I go to my explodey ball and I explode myself, you see that the room fills out rapidly because it's moving faster than is realistic, simply because of how fast the simulation's running, which is a sign that I've done a very good job optimizing this code, and I am quite happy with it. But that's not the only thing that I was working on. The reason why I got into this query of why is my code slow is because I was adding force as a result of exchange of matter between the tiles. Obviously, if there's a hole breach, there should be things sucked towards it. So I was working on trying to figure that out. And as it stands right now, I have a pretty happy starting point. I don't think the math for the actual force is accurate yet, but the directions and the way that it affects things is added. So what we're going to do is create a hole breach and see what happens. Pick this nice middle tile. I'm going to delete it, and don't blink. It's going to happen really fast. Actually, let me get ready to pause it. So I immediately, as I add that, it starts creating a vacuum, obviously, and it empties out the contents of that tile. Then it interacts with its neighbors and creates a flow of air toward it that it continually empties out. Now, as that force is applied, as the matter is exchanged, the game code keeps track of the direction and the amount of mass being moved, and it adds that to a value to the jar. Then, when the tile updates, or rather the space of the tile updates, it then checks to see, do we have force active in this jar, and do we have rigid bodies within the tile that can be acted upon? And in this case, yes. And there's all the gibs from my corpse. And then there's the explodey ball itself, which is a rigid body that is in an area that has mass exchange that is significant enough to exert a force on those objects of that size, which is significantly, perhaps unrealistically right now because I haven't sorted that math out yet, but you can see that things fly. And I think that is realistic, that when the pressure is so high, it'll actually fly over the hole. It won't just like shoot straight down it like those photon torpedoes that blew up the Death Star. It kind of overshoots it, and then it'll shoot back once the pressure reduces and the amount of force being exerted on the objects is smaller than it is right now. So we'll watch that play out and check the frames. It should stay about 60 frames per second. Or 50, I guess. That's fine. Oh, that's funny. I've never seen that before. The visors blocked the ball. But that's the gist of it. Oh, my camera's following the brain out in space. There we go. Oh, and see, because now the gas pressure for that tile is so small, there's not actually enough force being exerted on the glasses to just shove it outside. Yeah, I'm happy with that. It took a long time to get that working and get that working fast. I need to change the way that pressure affects the flow of fluids. I think it should be emptying out, at least around the edges. And I need to think of a way of how I want to do like evaporation and stuff, because blood shouldn't just... The blood presence here is going to be really, really, really small, I think. Yeah, it's like... I want to say that's like a cc, like 7 cc's of blood, but it completely covers the tile, and that's no good. But that's where I'm at. Game is running really fast now. Very happy with the progress on that. And that's glitching out because we're at such an infinitesimal amount of matter for the liquid. It's rendering basically nothing, to the point where it's overlapping the textures as the station empties out. But the gas exchange works great, works really fast now, and now the force is starting to take shape, and hopefully we're going to get some really realistic breaches and stuff where I can see things flying around the room and being all crazy. Like, it doesn't affect people yet, though, because of how player controllers work in Unity, but it can be made to work properly. And that's it. Thank you for watching this 10th update, I want to say. Hopefully many more to come on this game I will never finish.